allow you to just run it as it is. You click this link, and then you're taken into this Colab notebook. If you have a Gmail account, you can just log in and use it, and you don't have to install anything. So I hope this is going to be the easiest way for you to join. If you prefer to run it, just run it as it is. Okay, sorry, I had my YouTube stream on my phone, and that started running. I wanted to see when it started. So basically, if you want to run it on your machine, you can just copy the materials, this repository, run the setup check, which will check whether you have a Python 3 version, at least 3.5. Libraries like NumPy, Pandas, SciPy, Matplotlib, Seaborn, and Jupyter Lab, which are necessary to run this notebook. They should be pretty minimal. Okay, so I think we should just start. Can someone just write either in the YouTube comment or in Python webinar, so I know that you can hear me and everything is fine and you're following thus far? I'm checking Python webinar channel. Yes, awesome. Thank you, Alexandra. So I know that at least one person is listening and following. Great. Great. So if I'm gonna follow this notebook in on my local computer using the Jupyter Lab. So in case you would want to know how to launch it, you just have to navigate to your command line, activate Conda environment if you installed a Jupyter with Conda environment, or just run Jupyter in the directory where you downloaded the materials, and then run the command Jupyter Lab, and it should open up this, and you should select the Introduction to Python notebook, and then we can go through this. Okay, great. Another thing that I just will mention on the Discord channel, and hopefully in the description of the YouTube video, you should see a link to the evaluation form, which I would kindly ask you to fill, as we're very new with this webinar series and we want to improve on each iteration. So then we would ask you a couple of questions, how the tutorial was for you, and then based on your comments, we can make subsequent sessions more accessible. So, okay, so I'm a PhD student here in Oxford in Genomic Medicine and Statistics at the Wellcome Centre for Human Genetics. Yes, I'm second year. I'm approaching the end of my second year, and I'm a computational biologist, and I do my PhD in chromatin organization in endometrial cancer. And I will be talking about Python today. So I started this notebook with this comic that talks about how easy it is to write things in Python. And I think I will be trying to make the case throughout this workshop that Python is actually one of the easiest languages, and that's why it's so popular, because many of the things that you just want to do in Python, you write them the way you want them to be done. The way you think about it, you just write it down, and as long as you comply with the basic rules, you can make your computer do what you want. So in this comic, actually, they are comparing Perl, and one anecdote I heard about the differences between Python and Perl is that Python, because it was written by a mathematician, is quite deterministic in the sense that there's always usually one or maybe two ways to do something, but like one right way to do something, where in Perl you have many different ways, which makes it a bit more complicated to understand other people's code. So what are the Python advantages? So one thing is that it's easy to read and easy to learn, which is my other point, that if you're going to see some program written in Python and you're going to read it to yourself, it uses English language. So if you want to print something, you're going to use a word print, or if you want to perform some kind of operation, it's going to have instructions in English, and it should be quite easy to read, and it should be quite and it's formatted in a way that it should support readability. The second advantage is that it's the vast repository of libraries, providing necessary extensions. So for those of you who are coming from R and are trying to branch out in Python, it also has a lot of similarly to what R has with the CRAN packages and other packages that you can just install. And it's portable through platforms, which means that you write your program and you don't really, as long as someone have a equivalent, a good Python version installed on the computer, you shouldn't be you don't have to worry about whether it's going to run or not. So you don't have to worry if someone will run it on Linux or on Windows or Mac, because that's taken care of by the Python interpreter. It's easy to leverage other languages' speed. So again, for those of you who are from R, it's quite easy with R to go to C++ if you know C++ by using RCPP. And here I would say that it's even easier in Python to use the advantages of C. As one of the examples, when I was profiling my code writing a tool Sonics, I was just able to write the code as it is and run Cython on it, which is an extension to Python, a module to Python, which can take your code and translate it into C and compile it so it's faster. And even without adapting many changes to the code, you were able to leverage some of the speed of C. So I think it's quite easy to navigate and quite easy to leverage. And Python is object-oriented, and unfortunately, throughout this workshop, we're not going to focus on as much on object-oriented, and that's something I would want to extend in the future, maybe, to introduce more object-oriented programming in the tutorial, because it comes in handy quite a lot later on. But basically, all you need to know is that it's object-oriented and it's really to implement object-oriented programming in Python. But here we're just going to leverage that, but we're not going to write classes, unfortunately. So we'll be working with Python 3. I would expect you to all have at least Python 3.5. We were going to use one or two advantages of 3.6, and I will say it. I will mention that this is a feature that was implemented in the 3.6 version and earlier and latest. But throughout this, if you have a 3.5, I have tested it on some will work properly with previous versions. There might be some cells that will not run. Yeah. And we're going to start with basics. So we're going to go through variables, types, lists, controlling the flow, functions, and modules. And then we're going to go into the second part of the tutorial, where we're going to explore data analysis with Python. So we're going to use NumPy and pandas. We're going to use NumPy to multiply matrices and solve equations. Just one promise, not too much math. We're also going to use pandas to read in Penguin dataset, and we're going to use SciPy to investigate differences between the groups and just apply basic statistical testing. And we're going to plot a little bit. And recently I added Seaborn to this workshop because I decided that it's a bit unfair to compare Python with just matplotlib to, for example, R and ggplot2. So I added one exercise with Seaborn that we're going to be going through. So before we're going to start, there is a short note on code styling, is that the very best advice I received about how to write code and which style to use is that it doesn't really matter as long as you're consistent, because you're never going to use the best code styling. You're going to use the best code styling that is the best for you. Or if you're gonna write a collaborative project, you're gonna have to agree with your collaborators on a proper style. But there's no one that is better than the others. It just whichever suits you more. And as long as you're consistent, everybody can read it and can understand it. And one note on variables. So I chose, I like lower snake, which is the way to name variables. I don't understand why this is not showing up. Hopefully, this is quite a pretty illustration. Oh, never mind. I'll look it up later. So there are different types of naming different styles of variables. So one of them is when you're using a capitalized letter and obviously no spaces. I use all lower case and underscores, but feel free to use whatever you want. As I said, as long as you're consistent. Okay, so I hope everybody has have their notebooks open, and this is the time for the first line of code that we're gonna run. So if you're new to Jupyter Notebook, when you have your Jupyter Notebook open, you can just press play when you select the cell, which is gonna work just like this. And what I did here is I just asked Python to print a very short sentence, "Hello world," which is historically the first thing everybody should do in a new language or in a new platform. And I'm just gonna, for those of you who are using Colab, make sure that everybody can follow. I just open this and show you how to run this, so we're all at the same pace. And so this is the picture I wanted to show you. I don't know why it doesn't work on the Jupyter Lab, but this is screaming snake case where everything is. There's camel case where each word is capitalized. The first one is lowercase, and this is the snake case, which is the underscore. Yeah. So when we navigate to a cell in Jupyter in Colab Notebook, we can just press play. We just press play here, and it should execute. It's kind of expecting it to execute a bit faster. Yeah. But it has to probably allocate us some RAM and this. I am sharing the screen because Alexandra Isinkova asked, "Can I please share a screen?" And I do. So if you're following on Discord, you can navigate to webinars and then double click on my sharing screen, and then it's gonna pop up. But yeah, I am sharing a screen. So I hope that some helpers will help you navigate to this. Okay, great. So we did ask Python to do one thing, and we can see that it did exactly the same thing in the Jupyter Lab and in Colab. Awesome. So now it's the very first exercise you're gonna do, and you're gonna do it alone. So what I want you to do is to write your first line, which is going to ask Python to print hello and then your name. So this is going to be done. I will work with you. So since my name is Kasia, I'm just going to ask Python to greet me by my name. And it did. Nice. Okay, so the first, I hope you can do it, execute it on your screens. I know that there is a bit of delay between what I'm saying and YouTube, so I'll try to wait a little bit in case people who are following on YouTube have questions. But I'm just going to comment make a comment about comments. So as you see, the second cell that we just executed has both code written and comment written. So as you see, if you're going to put a hash sign at the beginning of the line, it's going to be interpreted as a comment, which means that it actually is not going to be interpreted. It's not going to be run. It's just going to be left there as an information for future self, for yourself or for other people who will be reading the code. And it's very important to make as many that's not true. It's important to make comments and to explain what is happening with your code. Too many comments might also not be the greatest, but it's better to have comments than not to have them. And there also, so there's one way of making a comment, which is by using a hash sign. You can also use, if you want to have a multi-line comment, and those you can meet quite often when the functions are explained or where the classes are explained, where you use a triple quotation mark. So this allows us to, instead of having to write hash sign at the beginning of every line comment, we can just use the triple quotation mark, and then we can make a multi-line comment. Okay. Okay, great. So I hope we can move on so far. Okay. Okay. So now we're going to talk about variables and types, and we're going to start with strings. So what are strings? Strings are just letters, signs, alphanumeric characters, just a bunch of characters encoded by either single or double quotation marks. So everything that we're going to put in there, even if we're going to put in a number, for example, if we would put 123 as a as a string, we can do it. Okay, so I'll do it here, even though this is a number, and we know that number, if I would execute it, it's going to be interpreted as string. And you can see that by having the single quotation mark around it. So if you would execute this, you understand that it's a string because it has a quotation mark. And we also can check the type of the variable in a second. So if I want to create a string variable, I use this syntax where I put a variable name here, then I write equation, equal sign. That's the word I was looking for. And then I put my variable. So this, for example, will create a variable called my string. And then when I ask Python to print this variable, it will print the string I'm expecting. So this is how we make an assignment in Python. And strings come with a lot of functions that we can use on them, and a lot of methods that we can use on them as well. So, for example, the easiest thing we can do, we can check how long the string is. If we execute this, the fifth cell, it's going to tell us that my string has 17 characters. So as we can see, every single letter, it doesn't matter whether it's lowercase or uppercase, whether it's a space or any other sign, it's going to be counted as one. And we're approaching a really nice thing, and something that's very important is that Python counts from 0. So this is a really important thing, especially if you already are familiar with programming and you use R, because R starts from 1. So if you want to access the first position in R, you just access the first one. But in Python, we should think about it as how many positions since the beginning. So if we have 0, that means that this is the beginning. This is where we want the very first element. So it's a bit different thinking. So if I put in my string and then I put in 0, what I actually am asking Python to do is print me the beginning, 0 characters from the beginning of the string. And we can also get the characters from the end, and slices, which is we don't have to take one character. So what it allows us to do is actually access a specific location in a string. So let's say we're going to run my string 024, and this has printed 0, 1, 2, 3. So it's exclusive at the end. So it will run inclusive on the left and exclusive on the right. So it will run all the positions from 0 till 4, but without 4. 4 from the beginning, which would be 5. Also, we can access strings from the with minus with a below 0 or minus 0 in this case position. If we would put in here -1, this is again. So if we would think about it as position from the beginning, accessing the letters from or accessing strings from the end actually makes sense, because it says I want to access the -1 from the beginning. So I care from the from the last. I care about the last letter, or I can care about let's say third letter. Actually, by using this, I was able to extract the end. So I was so by leaving the second position empty, I just wanted for it to go till the end. It's very helpful if, for some reason, you don't know how long the string is, or you just it allows you to write code faster as well. Another thing is that we can use addition and multiplication on strings, which might sound funny if you think about it, because we are used to using addition or multiplication in maths. Yeah, so if we would create 2 new variables, which is my new string or my newer string, so the first one will be just my old string plus some other text, and my newer string will be just my initial string multiplied by 3 times. Okay, so my string is actually, this is my string. So this is what I created at the beginning. Now let's check what my new string looks like. And it's just like that. It's my old string plus my new string, and that just prints the message. And if we multiply, we're just going to have concatenated 3 strings. And as you can see, it just multiplied them. So it didn't add any spaces. It didn't do anything. It just multiplied 3 strings, one after another. So there are a few methods that are specific for strings. For example, this is find when we are interested whether there is a certain pattern in our string. We can replace them. So, for example, we would want to. We will see that in a second here in changing names. We can use methods such as upper or lower, which will bring our strings to either uppercase or lowercase. We can strip characters, which is extremely useful when we're processing files and when we want to strip characters from it. Or we can use also rstrip, which will do precisely strip with end-of-line characters, for example, or white spaces. So now we're going to create 2 new variables, and we're going to use a specific method for strings. So we have hello Kasia, which is just a string hello Kasia. And then we want to create Adam. And then we're going to apply this method on this string. So we're going to stop here for a little while, because so far we're going to talk more about functions and methods in a sec. But so far we were using a function, and then we provided our variable as an input, as you would expect, for example, in R, or as you would expect in school when you were writing that f from x equals something. So in this case, we're doing it a bit differently, and this is very Python specific, and it allows you to understand. So if you would actually pay attention to this line, we can see that hello Kasia is taken, and then something is done on it. So hello Kasia, we know that this is a string, and we know that then on this string there is this method called replace applied. So that allows us to write it down in a way that we can process what is the input, what is the method that is applied. Another thing is that we can stagger a couple of methods on top of each other, as long as we make sure that the output, the class of one method is the input class of the second method. So let's say we have hello Kasia here, and then replace. We can also put another method, which would be upper, for example. So if I run this, and then I run the second cell, I now am shouting hello Adam, because I've applied upper on the output of the replace command. So what I did here is I taken hello Kasia string and replaced word Kasia with word Adam, and then I made it to upper. So I changed the case of this, and I shouted it out. I hope everybody is following so far. Please, lost, just write a comment under YouTube video or YouTube stream or on Discord, and there are a lot of small helpers that will, or big helpers, like awesome helpers, definitely, that will help you out, or they can raise the question to me so I can answer it on stream. Yeah. So for example, this is another method, and we're gonna see that if we're gonna take a deep quote, be yourself, everyone else is already taken. And then we're going to split this deep quote by letter E. So we expect it to be yes. And we're going to talk in a second, but this is what I was talking to you earlier, is that this is no longer a string. This is a list of strings. So because we used the function that's we used a method that's called split, and it split everything into smaller chunks. So it extracted the E and decided that at wherever E letter was present, it would just split it. So it doesn't make as much of sense if we're going to use E. But for example, if I would want to split this string by semicolon, it would do this, which will be two different parts of the sentence. So be yourself as first instruction, and then argumentation, everyone else is already taken. And we can split it by multiple characters, which allows us to also remove the space here. Okay. And this is another example of staggering them. So we have another string here, which is two things are infinite, the universe and human stupidity. And I'm not sure about the universe. It's attributed, I think, to Einstein. I have no idea whether it was truly said by Einstein. So before we're going to move on to the staggering of methods, I just want to make put it to your attention that I have used here single quote and double quote. And I use that because in this, so I use it here mostly because I wanted to show that if we're going to use both of them, the one that is inside the string will be just used as a decorator. So it won't be interpreted as a character that will tell you what kind of variable you have. It will be part of that variable. So before we're gonna proceed here, I'm gonna split this. Hopefully, yes. And I'm gonna print this so you can see. Yes. So as you can see, now it has this inside. Okay. And another thing that is interesting here is that even though there is a special character, which is the end of line, we are unable to see that here. With it gets to do with printing. We could use a different method to print them out. I'm not going to this at the moment. So if I apply this one, it will create a list of strings again. And as you can see here in the 21 cell output, this is part of that. So the double quotation mark is part of the string here. And another thing is that since we used a single quotation mark as a way to tell Python that this is going to be a string, expect a string, we have to use an escape. So we have to use a backslash if we want to use this quotation mark inside the string as part of the sentence. So here, because we want to say a shorter version of I need to use backslash in order to tell Python that don't end this string at after I still want to go further. So this is going to be so-called an escape. And again, we first removed the end of line, then we changed the case to lower, and then we split the string by a space. We have double quotation mark 2 as first string, things are, etc. So the same thing we could do, the same thing as we did here with 3 staggered methods, we can also do with intermediate steps. First, I'm going to prove it that it's working. So we get exactly the same output, but the bad thing about it is that, the disadvantage of this is that we have had to create a lot of variables, and it becomes increasingly hard to create really good names for those variables. And also it had taken us 4 lines. So I will answer Ryan's question in a second, but I'll first finish my thought. So it's better if we're gonna use 1 line as here, because it explains that an input of 1 and an output of 1 is an input to another method, and so on. And it allows us to write it in a more concise way. But it's not bad to use many lines, and definitely if we would add more methods that would be staggered on, it would become unreadable. And there's a rule of thumb to not stagger more than 3 methods in one line. And okay, and Ryan is asking, is saying that she doesn't understand quite well the role of rstrip. So rstrip is basically just a shortcut for strip, because we could use a strip function that will allow us a certain character at the beginning and at the end of the string. But since when you process a lot of lines, you want to get rid of all the white spaces that are at the end. So you want to get rid of the spaces. Like, let's say you have a user input and you ask them for their name, and instead of just writing their name, they write their name space, and you don't care for this white space character, so you use rstrip. It's just a shortcut for strip and then space. And also, if you would have, like we had, an end of line, new line character, we don't need to store it in a string because we just want to get rid of it. Then we use rstrip, and it's just a bit easier to write than write strip and then the end of line character, or list all the characters that it can remove. So it's just a shortcut. Okay, now we're going to learn a bit. This is coming. The function that is only available in versions above 3.6 is coming as a 4th cell in this exercise. So don't worry if it doesn't work. I'll explain in a bit what it does and why. So first, before we start, you need to type in your name. Again, my name has not changed since I typed it in earlier. So type in your name and execute it. So you can create this variable, which is your name, and then execute the next line. So this is a couple of different ways to do the same thing. The goal here is that we want to For example, we want to communicate with a user. We create a script or a program in which we want the user to provide us some information, and then we want to print this information in a message. So let's say the same way we want to do it here. So I created a string in which I will greet someone to the Python class, and I want to fill some parts of the string and personalize it. So I want to use your name. So the first way is to put in %, and then S. And this is, and there's a lot of different letters here you can use, and then you can specify the exact format. So S is just a string. You can also use digits and then specify how precise you want the number to be printed. For example, if you have a very big number or a very small number when you want to include only a couple of numbers of precision, then you can specify it by providing it under the after the %. But we're not going to talk about it just yet. But so far, what it does is I specify 2 locations that can be filled in this string. I specified them by %, and I said that all that is going to be provided is going to be string, and it's going to be filled as string. So I provided first a variable, and then I provided a string Python, which I didn't save to a variable, but I just provided here. And then the message printed. Hello, Kasia, hope you're enjoying this Python class, and I hope you do. And we can do also the same if we want to name the variables, because if we're going to read the first string, and if we have just 2 locations, it's quite easy to grasp which one will go where. But if we're going to have many more, it might be more difficult to follow which variable should go to which place, and then we can name them. So here I say your name and then lang, because I will specify the y name is equal to your name and lang is equal to Python. And that gives us exactly the same. Just bear in mind that the syntax is different. And this is the third version, which I think is quite easier to use and doesn't need us to specify the names of the variables, because we can use the global variables, which are the ones that were already specified. So yeah, the difference between global and local in a very simplistic way is that local is local to this particular usage. So if I would want to access y name, it doesn't exist anymore. It exists only for the processing of the format function. While global name, like your name, which is a variable we specified here, and it's going to stay there until we want to use it again. And it exists in the whole of an environment. Then we can directly use them by using the specific syntax, which is F, and then quotation mark, and hello, your name, encoded, like name of the variable encoded in the curly brackets. So this is just basically 3 different ways to do the same thing. However, they have specific usages and disadvantages and advantages. So it really depends which one you want to use. So the first case will be the easiest to format the variable if you want to specify exactly how many digits of precision you want to print. While the third one, for example, in my case, was the easiest to just say, okay, I want to use this variable. I don't need to specify it, specify its name. Okay. Are there any questions about strings or for? Okay. If so, just please ask them, and then I can come back to and answer them. I'll wait maybe 10 more seconds. And then we're going to move on to numbers. It's almost, we're learning a new language. That's why we're going through it like children learning a new language. We did strings, we did letters, now we're doing numbers. Okay, Alexandra Lysenkova asks, so %s is just any previously specified string. So %s is anything that you're going to put in here. So if you're going to look at the screen here, in this cell, we first specified the number of locations, and then we specified which variables, which things we're going to use to fill those locations. So one thing is that, let's say I would add another one, something, and that's going to generate an error because we have more ways to fill than the specific places. And if I would want to create a place for this to be filled, I would just use %s. Yeah, so I just added another thing. If I would want to do the same in a second, specific, like in a second way to do this, I would write this, which is specifying a location and then specifying what I'm going to fill. And this, the advantage of this method over the method above is that I can do, which is move the order of the variables that I will be using to fill, but it will still stay the same. So this is the advantage. I don't have to remember where exactly I'll put it. As long as I name them, it will know exactly where to put it. Okay, great. So now we're going to numbers. We have two different types. Types to talk about number in Python. So we have an integer and we have a float. And the difference is that, integers are just in the same way that they are in real life, which is just integers. One and a half is not an integer; it's a real number, and integers are just the whole numbers. So we have integer and a float. When we're going to print them, we see that they are saved. We can print them and access them. So one thing is that integers are much lighter because if we're the integer type, Python already knows that it's going to be a light number, 1 or 3. It knows that it's a smaller set and there's less of the it will require less space to actually save this number. While for float, it will need more space. It will be a little bit harder it will be a little bit harder to express. And one thing is that if we're going to add two numbers to each other, like my float and my integer, we're going to change the class of the variable and the class of the variable. So if I would add two integers, it's still going to be an integer. But if I'm going to add integer to a float, I'm going to get a float. So another thing is that we can use Python as a calculator. The second phase thing, because like the first thing was to print hello world, but the next thing is to try it out and Python adds numbers. And so first exercise, proper exercise where I don't tell you exactly what the result is. I want you to multiply the remainder of the 456 by 87 and by 21. So I want the remainder 456 divided by 87 and the remainder of that, then multiplied by 21 and the whole thing raised to the power of 3. And then get a floor division of this number by 11. It's a bit convoluted, but I wanted it to be a bit more complicated so you don't do it in your head. I mean, there probably are still people who can do it in their head, but yeah. So Python largely follows the order of equations as does math. If I recall correctly, I'm pretty sure, yeah. So you have to use brackets if you want to type in something that should be done before the other multiplication, the other another operation. So modulo is the remainder of the division. So I'll give you a hint with this. So if I want to have the remainder of the division of 456 by 87, I would just write in this. If I want to multiply something So if I would run this, it will return a number that will be lower than 87, between 0 and 86. So modulo is if I would write, for example, 16 modulo 4, it will return 0 because 16 divided by 4 is equal 4 times 4. If I would write 17, though, it will be 1 because 17 is 4 times 4 plus 1. So for those of you who might not be familiar with modulo, this is what I mean. So again, it's a bit difficult when we are not in the to conduct it because I don't know. I don't get a sense of how well you can follow this. So I'll give you a little bit of time. And if you ever rewatch it, you can yourself, but I'm just gonna write down the answer. Oh yeah. And let's see whether I got it right. Oh, I didn't. Oh, well. Multiply by 21. Multiply the remainder of division by 87 by 21. Oh, raised to the power of 3, of course. Yep. Sorry. Great. So yeah, so this is a point that I should make, that numbers are easier for humans than they are for the computer. Is that computers are in the base. Computers live in a world that is a base of 2, while we live more in a world that is a base of 10, like we use in everyday life. So when we represent a number, we usually think about how many tens there are in the number, how many, and so on. While computers think about it, how many 2s or 2 raised to a certain power there is. So it gets way more complicated computer to express, for example, 1/10. For us, it's just 1 out of 10. For computer, it's going to be 1 out of 16 plus 1 out of 32 plus 1 out of 256, and so on. So the numbers are only approximations. They are not the exact numbers represented in computer. And that's why this equation, even though it makes sense for us, it is not true in a computer, because 0.1 plus 0.1 plus 0.1 is not equal to 0.3, because the precision on each number is different. And even though the differences are very small, they can add up and not be, and that's why they are not equal. The same goes for this. And only if we're gonna do this, which allows us to round the number to the closest 10, this will be true. So you need to remember, you have to have that in mind. So if you're working small numbers, you have to bear in mind that even though an equation would make sense on a piece of paper, it might not make sense. It might not result true. It might not be evaluated as true in a computer. So it as truth. So you have to remember that especially when you make comparisons. And there's a link that talks more about how the numbers are expressed and how computers think about numbers, if you follow this. We can mix numbers and strings. So here, the first thing is that we can assign multiple things at the same time. So if we're going to write A, B, C, and then 1, 2.0, 1, and 3, each variable will be assigned. A will be assigned with 1, B will be assigned with 2.01, and C will be assigned with a string 3. And this is a really nice function called type, and it will tell us what is the type of our variable. So for example, if I would check the type of another variable, that says that it's a string, as it was. And we can mix and match. So we can mix strings and numbers. So we can also change them. So we can take a string and we can change it into a number, but as long as obviously as the string is representing a number, and we can do the other way around. So for example, we want to take the length of a really big number. If we were going to power of 1992, and this is not at all my age. And it has, if we would take 23 to the 1992, we will have 2,713 digits in that number. Okay, and now this is a question for you. If we're going to take A, which is we're going to take integer, we're going to change string into an integer, and then we're going to add it to string. How is this going to be different, or is it going to be different than B when we're going to take the other way around? We're going to take a string, then we're going to add it to another string, and then we're going to take an integer. So I'll give you a couple of seconds to think about this. What will be the difference? In the meantime, I'm going to just check Discord. Okay, no new questions. Okay, so let's see if they're different. They are not. Why aren't they different? Because if we did the first one, we just added two integers and then we changed it into a string. But with B, we just concatenated two strings. So what we got, it was actually 1, 2, 3, 4, 5, 6, and then we changed it into, which is 123,456. Okay. Next very important type is lists. Lists are the best thing about Python. We can store almost everything in a list. So we can create a list. List is created by using square brackets, and we can create a nested list, which is what we're going to do in this first example, where we create a list that has elements 1 to a list where we have a string and a number, and then we have 5.5. So basically, this first example is about to show us that we can mix and match different types inside the list, and we can have lists inside lists as well. And we can access them. Again, you have to remember that Python comes from the beginning. So if I put here start at 1 and go till the end, I mean start 1 from the beginning. So it's going to start from the element 2, then it's going to print the list 3, 4, and then the element 5.5. And again, if we want to only the two elements, we're going to print, for example, 1, 2, 3. We can also print the beginning, just one element. And also we can access the list from the end as we do with strings. And we can do similarly string, we can multiply lists. So if we're going to do my list times 2, we're just going to create we're going to create another list that will have the first list multiplied one after another. So we can also modify the elements, and we can assign, for example, we want to change the digit 2 to string 7, and we can do that by doing my list and the location of the element we want to change equals the new variable, the new thing we want to put there. And this is going to be an interesting lesson. So first, we're going to create my list 2, which is going to be equal to my list. And if we're going to print my list right now, we're going to see that my list has changed, even though we changed my list 2. And this is a really important difference between R and Python, for example, is that the variables in Python are not copies. So if we're going to if we typed in my list 2 equals my list, we didn't really copy my list. We didn't create a copy of an object. We just we just assigned my list 2 to be referenced to the same object as my list. So it's a bit more abstract, but let's just dive into it for a little while. So when we create an object in Python, it is allocated some space in the memory, and then when we create pointers to it, which is the names, we just create exactly a pointer, like a direction where to whenever we want to use it. So if we just write in my list 2 equals my list, what we're actually doing is that my list references to this location, and my list 2 now references to this location as well. So whenever we introduce changes to my list 2, it also introduces changes to my list because it's basically the same object. So in order to create a copy, we have to use a special method, which is called copy. So now we create my list 3. And in this my list 3, we want to change the first element. And we see that my list 3 has changed and my list has not changed. So this is extremely important, because if you're going to use this to create a copy and you're not going to be taking into account that it did not create a copy, then you can change something in an object that you were not expecting to change. So whenever you want to create a copy in which you want to modify it, you need to use this copy method. We can create new lists by doing this, which is just an addition. So this has not changed the initial list. It has created a new object, which is the old object plus something else. We can modify the list if we're going to use append or extend methods. If we're going to use the methods append and extend, we're modifying the my list. So let's say, this the previous method where we just used my new list is equal to my list plus new element has not changed my list, as pointed here as a second line. But now when we're going to append new, we're going to see that it did change. So we see that my list now contains new element. And if I would run this cell again, it will add another new element, because that list was already changed, had already had a new element, and I added even a newer element. And there are two methods, append and extend. So append will add, you can see the difference if I will just run them. So append will add an element to the list as this element, while extend will extend the list with the content of another list. So what happened here is that first comment append added a list as an element of my list. So it added a list of 1, 2, 3, 4 as a 1, 2, 0, 1, 2, 3, 4, 5, 6, 7 element, while my list extend, when it took list 1, 2, 3, 4, actually added 1 as element 8, 2 as element 9, 3 as 10, etc. So those are two different, depending on what you add. So if you would want to use append to get exactly the same thing as extend, you would have to do it 4 times. So you would have to write my list append 1, my list append 2, my list append 3, my list append 4, and you will get exactly the same thing as my list. Yes, and Now it's a question for you. Usually, if we would be to speak up, so I don't really know how to do it right now, but we have a list that has 4 names in it. It has Kasia, Jasio, Zuzia, and Amelka. Those are Polish names, so brace yourself. And the question is, what will names -2 output? In my head, someone answers, and I say, yes, it is correct. It is going to be Zuzia. And now, yes, thank you, Alexandra. Thank you very much. I know that at least one person is following. That is very reassuring because it kind of feels like talking to myself. Okay, sorted names. So I'm using a function sorted, and I'm taking the first one first, and I'm accessing, in this like an element that has an indice of 1. What will be the output? While I wait, I'll fix this typo. Jasio. Alexandra says Jasio, and she's correct. And if I'll take a length of list names from 1 to 3, what will I get? Will I get 1, 2, 3? How many elements will? Okay, I'll just run it. It will have 2 elements because names 1, 2, 3 will print Jasio and Zuzia, and those are 2 elements because the right-hand side is exclusive and left-hand side. Very good, Rihanna. Rihanna said 2. Great. Okay, so that was lists, and now we're gonna move on a few other types. Thank you very much. Carolina has posted a comment from YouTube which says that I'm not talking to myself, and that comments show up super late. Okay, sorry. I will try to be patient. It's not really my advantage. Not really my strong side. Strong suit. But yeah. Okay. So lists are really important in Python, and there will be as the more you're going to learn about Python, the more you're going to realize how good lists are. There is also something amazing which is called list comprehension. I will not be using it, I think, at least until later in the workshop, but it's a really great thing. So hopefully you'll learn to appreciate it. But there are also a couple of other types which perform a very specific function. So lists are very flexible. So we can have different types of variables and data inside and lists. But there are other tasks that need to be performed in Python and or in other languages, and there are other types of that. And one of them is tuples, and they are similar to lists. So there are a collection of items separated with commas, but they use, in order to form them, we use the parentheses. And then elements can be accessed by their position. However, when we define them, their shape is constant. We can no longer add or remove elements from them. And this is really important, for example, if we define arguments that we give to functions. If they have to stay constant, so then we can use tuples, or what we are outputting, so the output always stays of the same size. So I can create my tuple, and then I can again access the element that has an index of 2. We can get a part of the tuple. We can get 2 tuples, but this is not going to work. So that's also our first error, hopefully. And And what it says here, and this is a really good thing about Python as well, is that the error message is really good in that it says exactly what it means. So it says attribute error, and tuple object has no attribute. So it means that we cannot use append to modify tuple. And tuple will always have 4 elements. And that's that. Okay, Alexandra asks, in 1 to 3 position, number 2 doesn't actually exist. I don't know. I think it refers to this one. So let me just create a new cell in which we can go back and see if we would do this. We will get Yasha and Zuzia. So it means that it's going to print the element within index 1 and 2. The position number 3 is not included because the right side is not. So it basically tells Python, go until you reach position 3 and then don't do nothing. So you start at the beginning and start at the position 1 from the beginning. So start at the position, second element, but position 1. And then go until you reach 3. But when you reach 3, don't print it. So it's going to print 1 and 2, but not the third one. Okay. So we have worked through lists. We have talked about tuples, and now we're going to talk about sets. And sets are awesome because they're unordered, so we cannot access them by their position. But they're amazing in that we're going to put more than one element of each side. So if we're going to, for example, put 2 letters B, it's not going to have them both. It's going to keep only one of them. So if we create this, if we're going to create my set equals, and then we're using curly brackets, we're only going to have B once. So it doesn't clutter our set. So set is a unique. All entries are unique. So when we're specifying it, there's a lot of repetition. The set will not care for them. It will only keep unique entries. And sets are amazing if we quickly clean up our lists. So for example, we have a lot of lists. So we have a list in which we have element A, B, 3, and B. And we just want to get rid of all the repetition. We want to have only unique, for example. Then we create a set. And again, only have unique entries. But again, they cannot be accessed by indices because they are unindexed. And they cannot be multiplied because they only have, they only can have one element of each type. However, similarly to lists, we can add items to set. So instead of extend or append method that we were using on lists, we're using add. And we can use update when we want to use multiple items at once. I'm going to browse the comments now. How can you include for position? As Ulla said, so I'm really not sure how to read your username. Sorry for that. So how can we include third position? In the previous example, we can do that by just leaving the right side empty. For example, if I would want to include the third position, I would just write it like this, which is go to the end. Go to the end and print everything. If I just don't put anything. If I would do 3 like that, it will print the 0, 1, and 2 position. So if you leave it empty on either side, it will interpret it as the furthest you can go. Yes. And as Ulla says, again, Python starts from 0. So it indexes it from the beginning. So basically, when you want to think about locations in the list, you think about it how far from the beginning, either on the right or on the left side from the beginning. So you can. That's why it's really intuitive to think how to access elements from the end, because it's, if you would put your list on a circle, it's like going to the right, those are the positive numbers, and going to the left, it's the negative numbers. Okay, dictionaries. Dictionaries. This is another thing that I like about it, that it uses the names of types or functions the way we kind of would use them in English. So dictionaries, you can think of a dictionary as you would think of a physical dictionary, is that you can go through it, you can look up the meaning of one word, and then you're going to have a value. So dictionary, as does tuple, they use curly brackets, sets, I'm sorry, as sets, but it has a specific syntax, is that you have to define a key. This thing on the left is a key, and this thing on the right is a value. So if I create my dictionary here, I can create a dictionary in which I can look up how to say me in Polish. So this is a very, very, very short and not comprehensive dictionary in which I can specify that me in Polish is ja. So I can create a dictionary like that. We can also create dictionaries if we create them with the function dict, and that function can take as an argument a list. And this in this list, you have to have tuples in which you first write key, and then you write a value. And this is gonna get us that. If we were gonna write in 1, we would know that that is the number 1. So now let's see how to access it. My dictionary U, we can say ty in Polish. We can add new entries to the dictionary, for example. So ice cream and pizza is pizza. If we add this like that, we can update the dictionary. And we can also see, so this is gonna show you what happens if we're gonna create another entry for the same key. So for pizza, we can also say włoski placek, which roughly translates to Italian pie. But if we're gonna print my dictionary, we're gonna see that pizza action. So what that means is that keys can only be unique. So it cannot be that we have 2 entries for pizza and that they say different things. We could go around it if we would want to, for example, create this. Yeah. Oh, perfectly. Live coding is always fun. I mean, not for the person who's doing it. And we see that I made a mistake. Which, with this, we were allowed to we can add 2 different meanings to the same word. However, we cannot create 2 different entries. So we can have a key that will point to set of values, or a list of values actually, but we cannot have the same key to point to the different values. But we can have a different value pointing to different. So we can, for example, what we can, if we would create Polish to English dictionary, we could have włoski placek pointing to pizza and pizza pointing to pizza, because the values don't have to be unique. However, the keys have to be unique. We can access the keys and the values just by printing them like this. Okay, actually, in the interest of time, I think I will let you to do this exercise on your own later at home. later after the tutorial ends. One thing I should mention is that all the answers are put in Intro to Python answered. If you click on it, it has a file and all the exercises presented with a possible solution. So in some cases, it can be written a bit differently, but it is the same. So you can look it up, and you can always or write on Discord, and I'll be happy to help you out. But in the interest of time, we're going to controlling the flow. So this is the time where you can ask about either strings and numbers, or lists, tuples, sets, and dictionaries. So those are the 4 collections of items that we have in Python, and we use them for different things. Lists are the most flexible. The way to remember, the way I think about them is that lists are very flexible and allow to do many things. Allow us to do many things. Sets are unique. Tuples are constant in size, and dictionaries are allowing to name the elements and access them by name. Okay, I see that one person on Discord is asking, writing, so I'm going to give a couple of seconds. Okay, it disappeared, so I shall move on then. And now we're actually coming into a quite important section, because we're talking about the controlling flow. So this is how we're going to tell Python to execute instructions that we're going to give it, like which order and until which point. So we're going to start with logic. First thing is that we specify true and false as upper first letter T and upper first letter F, and then true or false, and they are equal 1. True is equal 1 and false is equal 0. And this is an important feature of Python, is that all objects are evaluated to true, except for the empty collections. For example, empty objects like 0, none, or empty string, empty list, empty tuple. Everything else except for everything that you would think of as empty evaluates to false. We have, if we want to say and, or not, or is, we're just using plain English words, which I think adds to the readability. If we want to do comparisons, for example, we want to check if one object is equal to another, and we use the symbols. We can say greater or equal, and they are put in the table. So we create those 1, 2, 3, 4, 5 objects. So first one is true. So the first question for me is, will A be equal to C? Yes, it will be equal to C, because true is equivalent to 1. It will evaluate to 1. Is A C? It is not. Those are two different. Those two point to different objects. But is D C, or is C D? Yes, they are. So as I mentioned earlier, if we're going to point to another object, if we're going to say C equals D, what it's going to do, it's going to create an object in which it will store number 1, and then it will remember that C points to that object and D points to that object, to that location. So they are the same. Is A not B? Is A not equal to B? Yes, that is true, because A is true and B is false. So a negation of false is true, and a negation of A is false. So if you write, Alexandra is asking, write 1 and it's not a string 1, then it will automatically be interpreted as true. It will be interpreted as true if I make any comparison, or if I phrase it in a way that Python will think about it as a logical. But another thing is that I can show you this. And then I will do this. Okay, so yeah, so it will evaluate to a number. So we're gonna see if loops. If I would put there if, and then I would put a number that is bigger than 0, then it will evaluate to true. However, in this case, when Python is doing a comparison, it was checking whether it's equal, and the first thing it does, it checks whether the numbers are equal. So it will be, so again, coming up with reminding the question. So if you write 1 and it's not a string 1, then it will automatically be interpreted as true. So actually, in this comparison, in this comparison, A equals C is actually evaluating true to 1, that way around, and it's checking whether 1 is equal 1, because it is a number. It is a number, and there is a hierarchy of what it is how it's gonna compare it. So if there are 2 logical values, it will keep it at a logical level. But if there is a logical value and a number, it will change the logical value to a number. And we can write more complex statements. So, for example, this will follow all the rules, which is if we have false or false, it will evaluate to false. If we have true or false, it will evaluate to true, and so on. Yeah. And this is a way. So if we would, and then if we would check if length of the list is bigger than 0, it will print print this. I don't think that was what I wanted to do. I think what I wanted is this. So first of all, I just size of the list is bigger than 0. It will evaluate it's true, and then if I run it again without specifying, without asking whether the list is empty, if I would just use if not empty list, what it does in this comparison, it will check what this object is evaluating to in the logical space, and because it's not empty, it will evaluate to a true value. So that's why it will print. So yeah, so if I have a specify an instruction here, it will only be evaluated if this condition is true. So if it's true, this is what it's going to do. And now, if I do an empty list, if I have an empty list, if I put in if not, which is a negation, it will print this thing, this line here, and it will print this list isn't true. Okay, Ryan is asking, I don't understand why the 110th line returned true. Okay, so let's split it then. Okay, maybe I should create a new cell. Okay, let's check R or B, what it will evaluate to. It will evaluate to true, and A and not B will evaluate to true. And then if we're gonna have 2 values that are true and true, it will also evaluate to true. So if you have AND, you have to have both of the things in a comparison equal to true in order to return true, everything else to false. And because B is false and we take a negation of false, which is true, we have the whole statement equal true. So in this case, if you want to see, you have to first make sure that this comparison, what this comparisons evaluate to, and then check what is here, and then check. And this is also maybe a way to mention, and that if for example A or B, if in this comparison we would have two falses, and this will evaluate. Python will not check the rest because it doesn't have to, because it already knows that if this is false, then everything, it doesn't matter whether how much right, it already knows that it's false, so it won't evaluate it any further. Okay, this is an important thing because, so I told you that first non-empty objects evaluate as true, and also when we make a comparison between a biological value and a number, it will be evaluated in the number space. So this is going to be interpreted, so false or false, we're going to negate false, and it's going to be true because it's going to be true or true. Then we have a reminder of division 247 by 5 and 230 by 2. So this is going to be bigger than 0. This is going to be equal to 0. So we have true, and then we have false. So we take true, and then we take a negation, which is false. So we have false or false, and it's going to be false. But, and if we would do this, it will evaluate to true. But let's think about it. So this evaluates to false, and this should be true. So our intuition would tell us that it should print true. However, the result will be, at least for some of us, a bit surprising, because it, instead of evaluating and printing the evaluation, it has printed the object itself. So this is an important lesson to remember, that if you would use those objects for evaluation, you need to be very cautious of what is actually being printed out. Okay. There are a couple of questions. So what is the result of 10 equals string 10? And a question from the audience, what does exclamation point equal sign mean? That means not equal. So it's a negation of. So if we have both, if we have 10, is 10 not equal 9? Yes, it is not equal 9. Okay. What will print 10 equal string 10 print? It will print false, because number 10 is not equal string 10. What will print not true or false print? I hope everybody is saying out loud that it will print false, because or evaluates to true, and then we negate it, which is false. And what will this print? It will print false, because we have an object that is not empty, and then we negate it, so we take false. And this is a really, really interesting thing, because we are doing a comparison between two strings, and we're basically asking a question: is bug bigger than apple? And interesting thing is that it does a comparison based on the, how it translates the string into a numerical value, and then it will say that it is bigger if the sum of letters as encoded in a specific encoding is bigger. So that's why bug is bigger than apple. And to be fair, I don't really remember whether it compares the whole string or just the first letter. I will check it in a second and then come back to it. But yeah, so you have to be really careful, because first of all, I cannot think from the top of my head why you would rather think numbers. So the bad thing is that if you want to compare numbers and by some mistake you will save the numbers into strings, you might be surprised with your result because it won't always evaluate to what it wanted to. So it is always good to remember that in Python, everything has Boolean value, so it won't throw you an error. Okay. Now, conditions. So those are the most important thing that will control what is happening in your script or in your program. If you have an if statement, an instruction will only perform if it's true, and then you can have more. If you can specify if this is true, then do this, and otherwise do this. So that's how we use else. And this is going to be a bit interactive. So run it, and the prompt will ask you provide a number greater than 0. So if I put in 8 and I comply with it, will print thanks. And if I run it again, I hear someone in the background. I think someone has not muted themselves. Don't know if you can look that up. That would be awesome. Okay. In the meantime, please provide a number greater than 0. Let's see. What if I will be a -8? And it will tell me that -8 is not exactly greater than 0. Good. And now we can have also 2 conditions, and then we can have 2 specific conditions, and then for everything else. So in this case, what will happen if I provide 0, and it tells me that 0 is 0. There. Yeah, I know the comments are so awesome. Okay, so in this case, we have if x, which is an input from a user, is greater than 0, then print thanks. If it's equal to 0, then tell them that it's not greater, because we're not looking for greater or equal, we're looking for greater. And for everything else, which is negative numbers, tell that it's not greater than 0. Oh, you're asking what curly brackets are in that code. So this is from the formatting, for the formatting. So in this case, I just put that I'm filling this space, which I created with format, with X. So I can also do it like this. And this will be more informal. Use a little shortcut and not name my variable. And also, since I'm using Python version 3.7, I think it was 3.6, I can actually do this, and it should understand me as well. Oh no, it won't understand me because I have one curve. So if I put 0, it tells me that 0 is 0. So I used 2 different ways of writing the same thing and filling the same space, similar spaces. So this is just to test whether our values, whether our conditions are fulfilled. We can also have loops, which allow us to do take every other number and print this name, which is I, because I am saying that for I in range of 1 to 10, and I'm taking every other number, which is this third argument 2, I will take this number to the power of 3. And it will do exactly the same, but I don't have 5 to the power 3, 7 to the power 3, and 9 to the power 3. So for E in range, for I in range, 1 to 10, range, if I would print this is just a collection. It's an iterative collection. I will have to do this. So it's 1, 3, 5, 7, 9. And so I takes 1 in the first iteration of the loop. Then it skips to the second one, which is 3. Then it skips to the next one, and the next one, and the next one. So it helps me to write this instruction in a more general, instead of specifying every single thing. Yeah, but like, let's say that we want to actually see a useful example. So we want to know, for what is the odds, what is a sum of odd numbers bigger than 0 and smaller than 100. And we can do that by creating a variable, which is an odd sum equal to 0, which will be updating as long as we go inside the loop. So what this code is saying, from I in range of 1, from 1 to 100, every other number. So take range 1 to 100 and skip every 2 and go every second number, is basically saying take all odd numbers between 1 and 100, left side inclusive, right side exclusive again, and then perform this instruction for every single such number. And that instruction is, to the odd sum, add this this number raised into the. And this plus equal is just an abbreviation for writing odd sum equals odd sum plus I to the raised to the power of 3. And this is going to be quite fast. So if we would want to write it down, we would have to write about 53 lines of code in order to get that number. And we can just do it with 3 lines of code when we just type it and write it in a more general way. So this was a for loop. So for every item inside specified there, perform this operation. Another loop we can have is while. So while will execute until a condition is met. So while true do something will run until the condition that is in while testing will be true. So you can write an infinite loop if you would just write while true, print something. So yeah, so we could do that. I don't want to do that because there's a very slim chance that I won't be able to break it in time. But we said that is greater, we're specifying that is greater than false. And while this is true, while not is greater. So because is greater is false, it will execute to true. So while this is true, perform this operation. So what I'm actually doing here is I'm doing the same thing we have done when we were testing if my input was bigger than 0 or not, but we're going to do it until I actually provided the one that I inputted once. So please provide a number greater than 0. Minus 9. Oops, it's minus 9. And it will tell me we are still looking for a number greater than 0. Please provide us with the number. So let's say minus 7. And it will do that until I actually cave and provide it with a number greater than 0. And now, so what had happened is that is greater is equal false. So we're performing this loop. Then it asks for x. Please provide a number greater than 0. I provided with the number minus 9. So it tests if x is bigger than 0. It is not. So we're going to else, and we're executing, which says we are still looking for a number greater than 0. And then we're going again. Checking is greater, still evaluating to false. Yes, it does. Now asks me for a number, and I'm saying minus 7. And again, it prints still looking for a number greater than 0. And then it goes again. Is greater is still false. So it executes this line, which is x equal more my input. I cave, I give it 8. and then it checks whether 8 is greater than 0. It is, so it changed the greater to true. Then it goes back to this line, tests if it's true. It's not, so it executes exits the loop and prints thanks. So this is the brief description of what has happened. And if we're in those loops, we can use more control flows tools, tools like continue and break. Break allows us to break from the loop. So this is very similar to what has happened here, is that if x is bigger than 0, I can just say break. So instead of creating a variable that I will change while a condition is met, I am saying just execute it forever until a condition is met and then break. So if I'm gonna run this cell again, it's gonna ask us questions, and then again I will do -8 and 9, and it behaved as we expected it to behave. We just run until I satisfy the condition. So another more useful example, have more than just one loop. So if we will have nested loops, so we test for one condition, and then we have one operation for one set of variables, and then we want to, on those variables, we want to do another loop. We can do this. So this is an example in which it will which will test whether the number is a prime number. So it will just tell us that 2 is a prime number, 3 is a prime number, 4 equals 2 times 2. So let's walk through this this loop. So for every n in the range of 2 to 10, which is going to be 2, 3, 4, 5, 6, 7, 8, 9, it will do for x in range of 2 to n. So then we have n, which is at the very first iteration equal to 2, and then we have x, which is going to be x from a set of from 2 to 2, which is just going to be 2. If n is divisible by x without any reminder, then we print that n equals x times n divided by floor division. And it breaks out of the second loop. Else, it will tell us that n is prime number. Yeah, so x in range 2 to 2 will not be just an empty set, so it will just not give us anything. So that's why print n is prime number, which is 2. Then it will go to another iteration of a loop where we're going to have 3. So now we're going to have 2, and then 3 divided by 2 is not equal 0. 3. The remainder of the division by 2 is not equal 0, so it's going to go to another iteration out of the range. So it will go to the else statement, and it will print that it's a prime number. And in case of 4, because we have so n is equal to 4, right? And x's we have 2 and 3, and we check that if we divide 4 by 2, we're gonna just have two twos, and it will not have any reminder of that division. So we know that 4 is divided not only by 1 and not only by itself, but it's also divided by 2, so it cannot be a prime number, and so on. If we want to see what is happening, we can add, and this is my first advice about debugging. So if we want to see what is happening, we can add this line. And n equal and then when we're going to execute it, so n is equal to 2, and then we don't have any x, so it just prints this line. Then n is equal is on in England right now, so please excuse it. Okay, so now n is equal to 3 and x is equal to 2, and we test division of 3 by 2, and we know that it has a remainder of 1, so 3 is a prime number, etc., etc. It allows us to see inside the loops. So print statement, adding the print statement is the very first way to debug and understand what is your code doing and how it is performing. Another thing is continue. Continue is allowing us to skip an iteration. So break will break the loop. So we're gonna exit the loop and we're not gonna go to the next iteration. While continue will skip everything after, and we'll just continue to the next iteration. So let's see this. Okay, so next line will not get exited. This is reached. So if a condition is met, it will print this. But instead of printing this, it will just skip to the next iteration. That's why we can print. We can check if a number is even or if a number is odd. This would be, we can do the following similarly, just this. So this is a different, so if we would test it, if a number is divisible by 2 without any reminder, it will print found an even number, else it will print found an odd number. But here we'll just have, we don't have else statement. Therefore, this line, if we do this, if I comment this line, if I don't continue, it will just print found an even number, an odd number for the same number, if it is an even number. But if I add continue, it will, as long as it already printed that it's an odd, print that it's an odd. Okay. So again, this is an exercise I want to leave for you. I would normally ask you to do it, and then I will help you out, figure it out in the room. But yeah, but in the interest of time, I think we should go on to functions. So just please do this exercise later. You have the answers in a into the Python notebook, answered notebook, or if you have any problems, I'll be checking the Python webinar Discord channel. So if you have any issues, just basically text me. Functions are awesome because they allow us to write the chunk of to execute and specify output. And if we have something that we do a lot of times, we can just put it in a function. So we define functions if we specify function name and then function arguments, and then this is a body of the function, and then we can return or print. So for example, if we want to specify an addition, we would define a function that is called add, and we'll take 2 arguments, a and b, and then it will print the sum of a is equal and b is equal to, and this is what we specify. So there's completely no need to specify this function. We have an addition and we have a print, so we do that. But it's a good, in my opinion, example to show how that works. So I will now run this function. I will just run this function. I will add 1 and 4, and it prints the sum of a equals 1 and b equals 4 is equal to 5. And so this is really important, is that in a function, when we say a is the first argument and b is the second argument, when someone will provide an argument to your function, it will be, the first argument will be evaluated to b. However, if we were named them, if we specify them with names, we don't have to specify them in the exact order. And a little bit about global variables. I told you that we can have a local variable inside a function and then a global variable outside of the function. And this is an example of how that works. So we have specified x equals 5 and b equals 7. However, the sum is equal to 12. And that's mostly because, because b is equal to 5 because we did it as x, and a is equal to 7 because we specified b. So even though inside our function, so x is still equal 5 and b is still equal 7, and even though inside our function b will be equal to 5, that didn't change. It didn't change the argument outside of the function, and it still took b as 5. And there was a question about one equal signs and what are the differences. One equal sign is an assignment. So when we want to assign a value to a variable, we use one equal sign, and when we want to compare and see whether they are equal to one another, we use double quotation mark. No, double equal sign. Okay. Let's write a function that calculates arithmetic mean, and that function will come in handy. We want to create a number s, which is an arithmetic mean of numbers, of even numbers. So we wouldn't have to create that, but specifying a function and enclosing a increases readability and allows us to adapt good programming practices, which is if you have a function that performs a single thing and you explain precisely what this function does, it increases the readability because a user doesn't have to understand and understand what is happening here. It can just either look up at the name of the function, which here is hopefully self-explanatory. But if they need more information, look up the function and see the description. Obviously, I have not put a really good description here. I should have written I should have written that this function takes input takes a list as an input and then calculates arithmetic. And that would allow us to adapt the very first good programming practices. And this is how that particular explanation could look like. So it calculates arithmetic means. This is the arguments. It takes list of numbers as arguments and returns arithmetic mean. And I added here a couple things which are a bit more advanced, but I'm just going to mention it. It allows us to test, and testing is super important. And I completely recommend you looking into which allows us to catch potential errors. So testing allows us to think, okay, so we're writing a function that should behave in this. What happens if it behaves differently? If it behaves differently, print an error that will tell something about it and what can happen as it is. So as just an example, I will tell you that I'm saying I'm trying this, and in case there's an error, if it's a type error, print this message. If it's a zero division error, print this message, and else just return. And if it well, then return result. Otherwise, if it's an error I have not mentioned here, it will print the native error message. So if I would just use this on my arithmetic mean, it will provide 3. If I would use arithmetic long, it will provide the same answer. So we know that they behave, at least partially, they behave the same. If I would use test2 on a list that has partially numbers and partially strings, it will just tell me the type error answer and types for plus, integer, and string. But if I would use arithmetic mean long, it will tell me, it will print my custom message. And in this custom message, I'm telling input must contain only numbers. Those are not numbers. So I did assume that, okay, sometimes a user may make a mistake. They may think, oh, I'm providing you numbers, but in reality, they do not. So I do catch those and I do print that those numbers are not actually numbers. And the same I do for zero division error. So in case I tell it, okay, input cannot be empty. I have nothing to divide it. Okay, so this is on testing. Obviously, the testing will come a little bit later down the line, but I think it's really important, and you should have it in mind. When you write a function, be very precise about what you want to take in as input and what you want to take out of that input. And I'm going to talk very briefly about modules. We have a lot of modules that are coming in the library, and they are described here. You're very well read about them a little bit more. So those are like modules like math or statistics, which provide you a set of functions and methods that math provides operation extension, which includes calculating factorials, and statistics will have some statistical functions, median, other calculations. Random will generate pseudo-random numbers, etc. And those come with the Python installation, so you don't have to do your own. Well, with others like NumPy or Pandas, when those are the libraries that provide extensions in a particular specific field. For example, NumPy is the fundamental scientific computing. It allows very easily to create arrays, matrices, and perform operations on them. So yeah, so for example, we import module as like this, so we can import random, and then we access each function from that module by typing this name and then .randint, which is going to generate an integer in random number from 1 to 19, which is 15 here. We can also import particular functions, and then we don't access them by preceding function name by the name of the package. We can if it's only a couple functions for all the functions, we can just use as star. And we can also change the names of the modules to abbreviate them and to make typing a bit easier. So for example, we can import statistics as st. Instead of typing in statistics every single time, we can just type in st.median. So for example, we import NumPy as an usually. And there are a couple of will be interesting for you. And again, please perform them on your own. And if you need any help, just again, contact me on Discord or on GitHub. And unfortunately, I have run out of and that has covered only the sections 1 and 2. The first section, which is where we covered the variables, types. We covered the control flow. We covered functions and loops. Yeah, so those are the basics, the very basics of the language. It still allows you to do quite. It will allow you, for example, to write a function speed of drivers. So if you would provide a speed to a function, it will tell you whether you deserve however many points you deserve or whether your license should be suspended. But what I wasn't able to do yet today is to run from the rest of the notebook. And if you want to, you can always run them on your own, because they are described and especially in the answered notebook. But we might also, if there will be interest, we can host a second session which will focus more on how to use Python for data analysis and exploration later. And with that, I will end. I will stay on. I think that the stream will cut off soon, but I will stay on to answer any. Thank you very much for staying till the end. It was quite a pleasure. And I hope that at some point we can be able to again. Fingers crossed. So yeah, if you have any questions, or any comments, it would be much better if anyone would join me here in my ear, talking maybe. Okay, so one of the exercises is you can write a function called, and the exercise basically boils down to checking whether a number is divisible by 3, by 5, by 3 and a 5, and then if it's not, to print a different one. So a hint is that you have if statements here. Okay, Alexandra is asking if I want to create a Python. I create a PyY file with all these comments. Yes, so we can actually try it out. So I can write a simple script if my computer actually allows me to. Oh my God. Yes, so I unfortunately won't. Or maybe I will. Okay, I can create a file that will, I will do this. This line is not crucial, but it can be there. And I will just run this as some. And I can save it as, and I will save it as my script, py, and I will, yes, I have saved my script. I will change the permissions. Yeah, I probably should not do this, but and well, this is what I did. So what I did, I created a script which had a command print this text, and then I run it, and I was able to run it with an executive mode because I specified that I want it to be run as Python 3, and then the bash actually checked. Okay, you want to use this program, so I'm just going to use this to execute this file. But I would also be Python 3 my script py, and then I wouldn't have to change to execution permission. Yeah. So that's this. You're welcome. And yes, I encourage you to fill the evaluation form and type in everything that comes, everything with this seminar. It is my first time giving it online, and it feels a bit weird. So I'd be very happy for any suggestions how to do this. Yeah, super good, Elliot. Elliot said 40 days into learning, and I'm really proud, and good job, everybody who stayed on and followed. Congratulations. I hope I didn't bore you. And again, if you have any questions, if you have any problems, always ask on Discord. And as I said, we'll talk among our organizers. And if there will be will to listen to the second part of the work, which covers libraries like NumPy and Pandas, to give it a go as well. So I believe that's the end of the questions, I think. So I'll just, I think I'm just gonna stop sharing my screen. Okay. So thank you, everybody. I'll be on the other side of the Discord channel and GitHub repo again if you need anything. But it was a pleasure. Thank you.